what is a standard deviation? The standard deviation of just a data set is the average deviation is the distance each data, and I'm going to call that X, falls from the average, from the mean, technically, which would be X bar. It's a measure of the spread of the data, how much it's scattered all over the place. For instance, say that I give a test and the test average is 70, and everybody in the class made a 70. Well, that means your standard deviation is going to be 0. What if I give a test and the test average is 70? And the grades were, they all fell between, oh, I don't know, 55 and 100. Which is probably much more common than everybody in the class making a 70. Or maybe I give a test and the test average is 70 and the grades were all between 0 and 80. Okay, the first one would be pretty unusual. The second one, the grades are between 55 and 100. That's probably not uncommon at all. And I wouldn't feel too bad about that one. If the test average is 70, but the grades are all between 0 and 80, and you could do that. If you've got a bunch of 80s and then 70s, and then you've got some in the 60s and 50s and a 0 thrown in, then, you know, you could still have an average of 70. So you got a lot of 70s and 80s, and then some really low grades. Okay, I would be much more worried about this one. So the standard deviation for the second and third test could be anything. But the last one would probably have the biggest standard deviation. I don't know, maybe, maybe not, because 80 isn't that far from 70. So we'd have to see. So how does one calculate a standard deviation? And you can see that it's much more valuable to have both the average and the standard deviation, because you're going to know a lot more about that test. Okay, so here's a set of numbers. Your standard deviation, and for a sample standard deviation, and we need to differentiate between the sample standard deviation and the population standard deviation. If you have the entire population And in this case, I suppose we could call it a population, but I'm going to call this a sample. If you have the entire population, then when you're getting your average, you can go ahead and divide by n. If you've got a sample, then you know that the sample standard deviation is not going to be exact for the population. And the reason we do samples is try to predict things about a population. So just like 1/5 is smaller than 1/4, which is smaller than 1/3, which is smaller than 1/2. As the denominator gets smaller, the fraction actually gets larger. So in order to make the sample standard deviation a little bit larger to try to get a better idea, because you're talking about the distance from the average. So you're going to get a better estimate if you assume the distance is a little bigger than if you assume it's tightly wound around the average. So they make the denominator a little bit smaller by subtracting 1 from it. So recall that what we're doing is we're getting the average of the distance between the x and the average. So we're going to sum those up. However, because we don't want negative numbers here canceling out positive numbers and making it look like the standard deviation is 0 when it's not, they square it and then they go back and take the square root of the answer. And as I said, this is divided by n minus 1 instead of n. The population standard deviation is actually divided by n, and that's the only difference between the two formulas. So you can't calculate the difference between each of these and the average unless you have the average. So we're going to set this up as a table. Our x's are 3, 3, 7, 4, 5, 1, 2, 7. To get our x bar, we want to get the sum of all of these. So I'm going to get the sum of these, which is, let's see, this is 10, this is 10, that's 20, this is 10, that's 30, and 2 would be 32. And then I'm going to divide by the number of numbers, 1, 2, 3, 4, 5, 6, 7, 8. So x bar is the sum of the x's divided by n. So 32 divided by 8 is 4. Now the next thing I want to do is get the difference between each of these values and x bar, the average, the mean average. So this one is going to be 3 minus 4 is -1. So this will be -1. 7 minus 4 is 3. 4 minus 4 is 0. 5 minus 4 is 1. 1 minus 4 is -3. 2 minus 4 is -2. 7 minus 4 is 3. Now I'm not going to sum this column up. Instead, I'm going to get every one of these numbers in the second column and I'm going to square them. So -1 squared is 1, 3 squared is 9, 0, 1, 9, 4, and 9. and then I'm going to sum up this column to get the sum of the x minus x bar squareds. So this is going to be 10 here, 20, 30, 34. So my standard deviation is going to be the sum of the x minus x bar squareds. Well, I could put it up here. This is going to be the square root of, this part is 34, divided by 8 minus 1 is 7. So it's going to be the square root of 34 divided by 7 is about 4.857, and the square root of that is about 2.2. So I didn't need all this extra over here. So the standard deviation for these numbers is 2.2. These numbers average being about 2.2 away from 4. Let's look at how you calculate the standard deviation of a frequency distribution. When you've got a bunch of numbers, but you don't have a lot of different numbers, then it's actually much easier to do this as a frequency distribution than to have to get your x minus x bar 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So n is 10. But notice that the range here, your range is nothing but the difference between the biggest number and the smallest number. So 7 minus 2 is 5. So there's 10 numbers, but they're all within 5 units. So if I were to write all of my x's down, I've got 2, 3, 4, 5, 6, and 7 are the only x's I can have here, since the lowest is 2 and the highest is 7. My frequency, I've got 3 2s, 1 3, 1 4, 1 2 3 4 5s, 0 6s, and 1 7. Now, in order to get my x minus x bar, I kind of have to know what x bar is. X bar, the mean average, would be the sum of the x's divided by n, but because I can look over here and use the frequency table, 2 plus 2 plus 2 is going to be the same thing as 2 times 3. So before I do this, let me take each of my x's, the 2 through 7, and multiply times that frequency. So that basically over here, I'm getting the sum of the 2's and the sum of the 3's. So this product is 6, 3, 4, 20, 0, and 7. This will add up to the same thing that I would have if I added all of these up. So 2 plus 2 plus 2 is 6, plus 3, plus 4, plus 5, plus 5, plus 5, plus 5 is 20. See why these are the same. So the sum of the x times f's for a frequency table is the same thing as the sum of the individual x's. So this is going to add up to, let's see, I've got 10, 20, 30, 40. This adds up to 40. Let me add up this column to make sure that I got all of my numbers here. 3, 4, 5, and 5 is 10. Okay, so there were 10 numbers. They're all accounted for. 40 So that means that my mean is going to be 40 divided by 10, which is 4. Okay, now I can do my x minus x bar. Coming all the way over here, 2 minus 4, so it's going to be x minus 4. 2 minus 4 is negative 2. 3 minus 4 is negative 1. These are all in order, so I can just go. 4 minus 4 is 0. This is going to be 1, 2, 3. Now, this is the difference between each possible x and the average, but I need to know how often that occurred. So, well, let me go ahead and square these. X minus x bar squared, because that's what I really need here, is how often the squares occurred. So each of these squared, I've got 4, negative 1 squared is 1, 0 squared is 0, 1, 4, 9. Okay, now I need to know how often this difference squared occurred. So I'm going to take the x minus x bar squared times the frequency, how often that happened. So it's going to be this number. Let me mark this with a different color. This one was this times this, went there. This was this minus 4. This was just this one squared. This, let me change colors again. This one is the product of this and this. So I take that times that goes here. So this times this, f times x minus x bar squared. So I've got 12, 1 times 1 is 1, 1 times 0 is 0, 4 times 1 is 4, 0 times 4 is also 0, 1 times 9 is 9. I need to get this sum. The formula we're looking for a frequency distribution is that we're going to take the sum of the x minus x bar squareds times the frequency. Again, we're going to divide that by n minus 1. And again, we're going to take the square root of the whole thing. So far, this column has the numerator. I need to square this. 1 and 9 is 10, 22, 23, 24, 25, 26. So this is going to be 26 divided by 10 minus 1 is 9. And again, that's done to deliberately make this turn out to be slightly larger than it would have been otherwise. So the square root of 26 divided by 9 would be the square root of 2.889. And the square root of that, 1.69967. So depending on how far they want to go, well, even if they go quite a ways, this is going to turn out to be 1.7. So that's how you calculate your frequency deviations. Your standard deviation of either a regular data set or a frequency distribution.